In this video, let's explore thermodynamic problems from the textbook. Thermodynamics helps us understand how heat is transferred and how energy is converted from one form to another. Today, we will solve a real-life problem based on heating water using a geyser. Problem statement: a geyser heats water flowing at the rate of 3.0 liters per minute from 27 degrees Celsius to 77 degrees Celsius. If the geyser operates on a gas burner, what is the rate of consumption of the fuel? If the heat of combustion of the fuel is 4.0 into 10 to the power 4 joules per gram? Step 1. Understand the physics. This is a steady flow heating process. Cold water enters the geyser. Hot water leaves the geyser. And heat supplied by burning fuel raises the temperature of the water. So, heat supplied per second equals heat gained by the water per second. Step 2. Convert flow rate to mass flow rate. The flow rate of water is 3 liters per minute. Since the density of water is 1 kilogram per liter, the mass flow rate is 3 kilograms per minute. Converting this into kilograms per second, 3 kilograms per minute equals 3 divided by 60 kilograms per second. That gives 0.05 kilograms per second. Step 3. Calculate temperature rise. The initial temperature of water is 27 degrees Celsius. The final temperature of water is 77 degrees Celsius. So, the temperature rise is delta T equals 77 minus 27, which is 50 degrees Celsius. Step 4. Calculate heat required per second. We use the heat formula. Heat equals mass flow rate into specific heat capacity into temperature change. The specific heat capacity of water is 4.2 into 10 to the power 3 joules per kilogram per degree Celsius. Substituting the values, heat per second equals 0.05 into 4.2 into 10 to the power 3 into 50. This gives 10,500 joules per second. So, the geyser supplies 10.5 kilowatts of power. Step 5. Relate heat supplied to fuel consumption. The heat of combustion of the fuel is 4.0 into 10 to the power 4 joules per gram. This means 1 gram of fuel releases 40,000 joules of heat. So, the rate of fuel consumption is fuel consumption rate equals heat required per second divided by heat released per gram. That is 10,500 divided by 40,000. This gives 0.26 grams per second. Step 6. Final answer. Therefore, the rate of consumption of fuel is approximately 0.26 grams per second, or about 15.6 grams per minute. Conclusion. This problem shows how thermodynamics connects theory with real-life applications, like water heaters and geysers. By carefully converting units and applying the heat equation, we can easily solve such problems step by step. OUTRO. If you found this explanation helpful, like the video, subscribe to the channel, and keep learning physics, one problem at a time.